Hello, hello, lovely people. How are you? Good morning, good afternoon, good evening. So let's try to resume our class by this recorded video. Okay, so if possible, some other time I may go to your classroom. Then maybe I'll, with the help of your PowerPoint slide presentation and the blackboard I might use. But let's see, let's venture with every possible way. Alright, so here in this first class we will repeat what we have discussed in the class which we discussed in that Zoom platform. Okay, so now we are to discuss about this Phylum Apicomplexa. Alright, so this group of parasites, they are quite large in numbers and they are hefty in numbers. So but these are not difficult at all, they are simple in their life cycle and in their pathogenesis. But one thing is that they are really important, especially in livestock and poultry industry. Alright, so Apicomplexa, when we talk about the phylum, so one thing which should struck your mind is there are certain organelles. Okay, unlike the multicellular eukaryotic organisms, let's say vertebrates, we are having different types of system: digestive system, reproductive system, nervous system, locomotory organs, and such and so forth. But here in this case, protozoa, they are single cellular organisms, but they are eukaryotic. Okay, that means they are having a true nucleus. Okay, so the functions of the organism is performed by certain organelles. Okay, so among these organelles there are some important ones. Number one is the micronym. If you see here, these small dots are the one that is helping in recognitions of the cell in which the parasite will penetrate, which type of cell. Okay, then secondly, once the parasite identifies which type of cell it is going to penetrate, this bar, the thing which I'm putting right now, the conoid, it is going to penetrate into the cell. Let's say, for example, in case of Eimeria, they are going to penetrate epithelial cells of the intestines. Okay, so once inside the intestinal cells, the parasite have entered in the intestinal cells, they are going to form a safe haven, so to say. That is, scientifically we call it as parasitophorous vacuole, or in other words we may call it as PV. Okay, so once the PV is formed inside the cell in which the parasite is parasitizing, there will be remodeling, that means reformation of the or restructuring of the PV, which is performed by dense granule. Okay, then we know that unlike in case of kinetoplastida, where the locomotion is performed by flagella, here in this case the most of the apicomplexan parasites, they are aflagellate organisms, except the stage in the male reproductive stage, that is the male gametes, that is having flagella. Except that one, none of the stage or none of the organism are having the flagella, so they perform their movement by gliding. The parasite is gliding over the surface by subpellicular microtubule. Okay, so one thing that is really important in the next important thing is their reproduction. This is the thing which is many a times that is causing confusions. Okay, so this group of parasites, they multiplied by schizogony or endodigeny. Schizogony is nothing but the multiple fission. Okay, multiple fission. We know that in case of entamoeba, they multiplied by binary fission. In case of trypanosoma, they multiply by binary fission. But here in this case, in case of protozoa, I mean apicomplexan protozoa, they multiply by schizogony. It is that the process is known as schizogony. They multiply by binary fission. One thing that is noteworthy is once the parasite is going to multiply, they swell up and they divide their nucleus into multiple times before the cytoplasm. Okay, so after the nucleus divide into multiple times, they migrate to the periphery of the cell, that means the periphery of the organism. Then its divided nucleus is integrated with some portion of the cytoplasm, and that becomes a daughter organism. That daughter organism, we call it as merozoid. Okay, one thing that is noteworthy here again is just before they divide, the swell up of organism, that is known as schizone. Please note this one, this is going to be important. Schizone is the one that is going to cause many a times the disease. Okay, or in other words, we may call it as many a times schizone is known as the pathogenic stage. Alright, so I hope with schizogony we are clear. Then the next mode of reproduction is endodiogeny. Endodiogeny is nothing but budding. Okay, from one organism it buds out a new organism. Alright, so but endodiogeny means where it is a short mode of internal budding, where from one organism there are formation of two new progeny or two new daughter cells. Okay, so but sometimes in case of toxoplasmosis, in addition to endodiogeny, there could also be endopolygyny. In other words, we may call endopolygyny as where there are formation of more than one, two daughter cells. Okay, so usually these are schizogony and endodiogeny are known as the asexual mode of reproduction, then which is then followed by sexual mode of reproduction by formation of male gametocytes or female gametocytes. Okay, as I told you, the male gametocytes, they are flagellate organisms. They are, that means the stage is known as flagellate. That means they are having flagella for their movement. They are much smaller as compared to the female gametocytes. So the male gametocytes, as it is smaller, it is known as microgametocytes, and the female, which is larger, it is known as macrogametocytes. Alright, so when there is okay, before that, the male gametocytes and the female gametocytes, they are having a haploid chromosome. That means they are having only one set of chromosome. Alright, so once there is formation of once there is fusion of the male gametocytes and female gametocytes, there will be diploid chromosome. Okay, 2N chromosomes, and the process is known as syngamy. Alright, so if there are many times when the microgametocytes or the male gametocytes is much smaller than the female gametocytes, we call it as anisogamy, anisogamy, or when they are of the same size, we call it as isogamy. Okay, sometimes there will be formation of spores, which is many a times outside the definitive host, so we call it as sporogony. Sometimes in case of theileriosis and babesiosis, the sporogony occurs in the thick salivary gland. Alright, so but sometimes in case of so we call them as we call that process known as sporogony, or in other words, it is the formation of infective stage. Alright, so if you see the classification, the order is Kinetoplastida and the class is Sporozoa, and there are two subclasses that is important. One is Coccidia and another one is Pyroplasmia. Okay, in case of Coccidia, many times the parasites are infecting gastrointestinal cells, GI tract, and sometimes some organism, they might also migrate out of the GI tract. Okay. On the other hand, in case of pyroplasmia, this group of organisms, they many times are known as hemoprotozoa, or they are many times infecting the blood vascular system. Okay, let's go down to Coccidia. That under subclass Coccidia, there is one order known as Eucoccididae. Okay, under Eucoccididae, there is one suborder, that is Eimerina. Under this Eimerina order, there are two family, Eimeridae, Sarcosistidae. Okay, in case of Eimeridae, the organisms solely they are going to infect the epithelial cells of gastrointestinal tract, whereas Sarcosistidae, we know sarcos, right? That means tissue. So they will be infecting apart from the epithelial cells of gastrointestinal tract, they will also infect tissue, sarcos. Right. So under this family, Eimeridae, there are genus known as Eimeria, which we know very well. Eimeria trenella, cecal coccidiosis, isospora, very important parasites, Cryptosporidium, which is causing diarrhea, and Teigeria Voinonella. Alright, so this is the typical sporulated oocyst of Eimeria. Okay, so if you see, where's my pointer? Okay, so let's see. First of all, when there is formation, when there is asexual reproduction that is followed by sexual reproduction, then the male gametocytes fuse with the female gametocytes by the process of syngamy. Here in this case, in case of Eimeria, there is an isogamy, so there will be formation of a zygote. Okay, so when after the formation of zygote, there is formation of the oocyst wall. Alright, so that oocyst wall contain the embryonic mass. Okay, so when this embryonic mass, alright, so when this oocyst wall or oocyst is excreted out in the environment, in favorable environmental conditions, this embryonic mass will divide into 4 sporocysts. Alright, so these 4 sporocysts will contain, subsequently, as we can see here, there are 2 sporozoid each. Okay, so I'm repeating, the embryonic mass will divide into 1, 2, 3, 4 sporocysts. Each sporocyst contain 2 sporozoid each. Okay, so the sporozoid is the one that is going to form a new organism. Okay, so this structure and all this, please go through by yourself. I will not go in detail. Okay, one thing that is important and noteworthy is at one pole, that means at one corner, the oocyst wall is thin. This is known as micropyle, and many a times this is covered with a cap known as micropylar cap or polar cap. Okay, so this micropylar cap and cap is very much pronounced in case of goat, G-O-A-T, goat coccidiosis, but many times it is absent in case of poultry coccidiosis. Okay, all these structures, please study it properly, and this many times we used to ask to draw in practical exam. Okay, so depending on the number of sporocysts and depending on the number of sporozoid which is contained inside the oocyst wall. Okay, so the oocyst contain different number of sporocysts. Each sporocyst contain different number of sporozoid. Okay, so based on the number of sporocysts and based on the number of sporozoid, the organism is classified. One is here, if you can see in the first that is Cryptosporidium, which does not contain, the oocyst does not contain sporocyst, and they contain 4 sporozoids. Here in this case, in case of Teigeria, the oocyst contain 8 naked sporozoids. Here in this case, in case of Sarcocystis, Isospora, Toxoplasma, the sporulated oocyst contain 4 sporozoids. The sporulated oocyst contain 2 sporocysts each. Each sporocyst contain 4 sporozoids each. In case of Eimeria, the sporulated oocyst contain 4 sporocysts. Each sporocyst contain 2 sporozoids each. In case of Voinenilea, it is here you can see here the sporulated oocyst contain 4 sporocysts. Each sporocyst contain 8 sporozoids each. One thing it is also worth to note down is, in case of laboratory, we can mimic we can perform the sporulation. That means, I'm just going back one slide, this unsporulated oocyst, that means the oocyst which is containing a embryonic mass, undivided embryonic mass, can be converted into the oocyst which contain sporocysts. The process is known as sporulation. This one we can perform in the laboratory by incubating in 2.5% potassium dichromate for at least 1 week. Alright, so let's see the general characteristic of Eimeridae family. Okay, as I have said, most of the members are intracellular parasites of intestinal epithelium. Their life cycle is direct, that means they are homogeneous parasites, and their multiplication undergoes through schizogony, that means by multiple fission, where there will be formation of a schizone. I'm repeating, this schizone is really going to be important in causing the pathogenesis, and the sexual multiplication by schizogony is going to follow by gametogony. After formation of gametogony, that means after the male and female gametocytes are fused, they are going to form a oocyst that is going to be passed out. Okay, then the sporogony many a times occurs in the environment, except in case of Cryptosporidium. The sporogony means where there is formation of the sporulated oocyst, okay, or sporulation we may call it as. It occurs in the environment. In case of Cryptosporidium, the sporogony occurs inside the host cell. Coming to the next slide, this is the typical life cycle of an Eimeridae family or Eimeria. Okay, I'm just going through. Okay, once the sporulated oocyst is ingested, they are going to release the sporozoid. This sporozoid will enter in the cell, okay, especially the intestinal epithelial cells. Okay, they are going to recognize the intestinal epithelial cells by microneum, and conoid is going to penetrate. Then rupture is going to form the parasitophorous vacuole. Then dense granule will remodel the parasitophorous vacuole. Okay, so subsequently there will be formation of a schizone. Okay, that means they are going to multiply by schizogony, and there will be formation of schizone. Okay, so this schizone, that means the swell of parasites, we are going to form a multiple organisms, and they are going to release the daughter cells. Okay, these daughter cells we call it as schizozoid or merozoid. So this merozoid might infect the new cell. Okay, they are going to infect a new cell, and they are going to form another schizone. Also, this is known as that the earlier one was first generation zyzone, and now it is going to form second generation zyzone. Okay, so this second generation zyzone, especially in case of Eimeria trinella, that is large enough and deeply seated, that means deep in the intestinal mucosa, so they are going to cause bleeding. That means they are going to rupture the cells, and in addition they are going to also rupture the surrounding tissue it containing blood vessels. That in that way there will be bleeding, and they are going to cause destruction of the intestinal epithelial cells as well as the surrounding tissues, so that's why there will be bleeding. All right, so after formation of second generation zyzone, then there will be merozoid that is formed. Okay, so this merozoid, they are going to form either male gametocytes and female gametocytes. Okay, so the male gametocytes, that means microgametocytes, and female gametocytes, that is macrogametocytes. Alright, so these microgametocytes will subsequently fuse the macrogametocytes or the female gametocytes, and there will be formation of the oocyst. Okay, so once this oocyst is formed, they're going to pass out, and in the environment within 7 days the embryonic mass will transform into 1, 2, 3, 4 sporocysts. Okay, so this is the life cycle. Okay, one thing I would like to say here again is in case of the schizogony. Okay, so let's repeat here once again. Here in this case the merozoid or the sporozoid enters in the new cells. They are going to form first generation zyzone, and that first generation zyzone is going to form merozoid, and this merozoid is going to infect a new cells, forming a second generation zyzone. Then that second generation zyzone is going to release the merozoid, then many portion is going to enter in asexual stage, that is formation of male gametocytes and formation of the female gametocytes. Some portion might enter on the new cells, forming the third generation zyzone. Sometimes in case of Eimeria acervulina, there could be formation of fourth generation zyzone, but this asexual generations or asexual reproduction does not continue many times. It does not continue indefinitely. At the most, they are going to form 4 generations. As I told you that in case of Eimeria acervulina, they are going to go 4 cycles. In case of Eimeria tenella, they may go 2 to 3 cycles. Okay, had they continue these asexual generations for long, they are going to destroy every living intestinal cell. But here in this case, there is a limited number of asexual generations, so they said in case of Eimeria infection, if there is no new coming infection, as this asexual generation is limited into 2, 3, 4 cycles, the disease coccidiosis is self-limiting. Why? Because as this is self-limiting, at some point they are going to enter in sexual reproduction, forming male gametocytes and female gametocytes. This is really, really important. Okay, so here I'm noting down coccidia infection are self-limiting. That is what exactly I said in the last slide. Okay, as the sexual reproduction does not continue indefinitely, so there is going to form, they are going to form at some point of time, they are going to form a sexual reproduction. That means they are going to form a gametogony, so there will be formation of oocyst. male gametocytes and female gametocytes, they will fertilize each other and they will form oocysts. Okay, so outside in the environment, the optimum temperature for sporulation is 30 degrees centigrade. Okay, in presence of a good oxygenation and in case of moisture. Okay, so let's see different types of coccidiosis based on different hosts. Okay, the first and foremost is in case of, in here, this bovine coccidiosis. Okay, so bovine coccidiosis, the mostly heavy infection of coccidiosis occurs in general, irrespective of bovine, caprine, swine, poultry. Many a times coccidiosis is a disease of young flocks. Okay, so the disease is, maybe we can say, it is many a times it is the disease of young animals, but that is not always, but this is many a times there is infection in case of young flocks. Okay, so let's see different types of different species. One is Eimeria alabamensis. The uniqueness is the developmental stage occurs in the nucleus of the host epithelial cells. We'll see in the next slide Eimeria arborensis. There is the oocyst is unique in the sense there is the oocyst having its coarse granulated mammulated surface. In case of in India we have Eimeria bombayensis. Alright, so here also I would like to tell you is that many a times we do not see the polar cap. In case of the area of in case of Eimeria of cattle, usually there is no polar cap. This is Eimeria arborensis, which is having the coarse granulated mammulated surface, and this is Eimeria buckinonensis, which is the largest oocyst of Eimeria. Okay, so coming to the life cycle of bovine coccidiosis or coccidiosis in general. Okay, let's see here and we will see this one also. Okay, so in case of the calf or the cattle, the animal have voided out the unsporulated oocyst, which cause sporulation in the environment, and in the environment from the environment the animal pick up a new infection, so the cycle continues. This is the direct mode of life cycle. Alright, so here in this case, once they enter, the sporozoid enters, the sporozoid will form first generation scion. Subsequently the merozoids of the first generation scion will form second generation scion. Alright, so this second generation scion, then subsequently they release the merozoid. So this if you can see here, this is the male gametocytes and these are the female gametocytes. Okay, the male gametocytes and female gametocytes. So these male gametocytes, which are flagellated one, they will fertilize the female gametocytes. I'm just going back one step. Okay, so once the sporozoid enters, they are going to form the first generation scion. Okay, so when the merozoid from the first generation scion is released, or when the scion, the dividing form, is broken up, they are going to infect the new cells, and once they are going to infect a new cells, then thing is they are going to enter on the next generation. That means formation of second generation scion. Here in this case, this is probably the life cycle of Eimeria bovis, where except in the case of heavy infection, the oocysts, which are big one, which is occurring at the top of the epithelial cells, even if these are very big one, they are not going to cause much bleeding. Okay, had this second generation scion, first generation scion or second generation scion, had this one occurs in much more in number, that means which if they occur deep in the cells, in case of Eimeria tenella, they are going to break open these cells, they are going to cause destructions here, so there will be bleeding. But here in this case, in case of bovine aimariosis or bovine coccidiosis, the thing is they are locating superficially in the epithelial cells, so there is not much bleeding, except in case of Aimaria zweerni, where the second generation scion occurs deep inside the cell, somewhere here, so there will be bleeding. Okay, let's see. In case of Aimaria bovis, the first generation scion, as I told you, the first generation scion, which is large one, they could be up to 400 micron. This but if this number 400 micron size is also formed, the number is not that big. The number of scion, first generation scion, is not much. That's why there is no significant hemorrhagic conditions. Alright, so the pathogenesis is mostly caused by the gammons and the oocysts. Here, formation of the gammons and the oocysts. Alright, here I have noted down the gammon is the most pathogenic stage. But they could destroy 20 billion of cells. If ingestion of 1,000 sporulated oocysts, they could cause destruction of 24 billion cells. Huge number. If you calculate one Aimaria oocyst one sporulated Aimaria will contain how many sporocysts? 4 sporocysts. Please do your exercise. 4 into, it's contain 2. Okay, so 4 into 1 minute. 4 sporocysts, it's containing 2. That means 8. Okay, 8 into 1,000. 8 into 1,000, 80,000. 8,000. 8,000. Okay, so in the 8,000 sporozoid enters. So the first generation scion might contain up to 1 lakh. Okay, so multiply by 1 lakh. Okay, so this first generation scion, this number one, if you multiply by 1 lakh, and these many numbers of sporozoid, okay, multiplied by 36 or 32 to 36. So ultimately you will get around 24 billion cells. Ultimately you will get around 24 billion. Okay, so this much number of cells is destroyed by ingestion of 1,000 sporulated oocysts. Okay, one thing that is again noteworthy here in this is the last one, that is in case of Aimaria barreilli, which is solely or exclusively infecting buffalo. Aimaria buckinonensis is the largest of all bovine Aimaria. Okay, I'm just going back. This is the Aimaria buckinonensis. So coming to the most important one, that is Aimaria zweerni. Okay, which is the most important one. In case of Aimaria zweerni, the disease caused by Aimaria zweerni is known as winter coccidiosis, which mostly occurs during winter, especially in case of temperate countries like in Britain and Europe and Northern America. Alright, so here in this case, as I have said, the trophozoids are found deep inside the intestinal wall, so they may reach muscularis mucosa. So by formation of second generation scion, there is going to cause destruction of the cell. So due to this destruction of the cell, or due to destruction of the tissue, they are also going to cause destruction of the surrounding blood vessels. So subsequently there will be severe bleeding. Okay, so Eimeria zwerni is the most pathogenic due to the locations of the parasites, which is deeply seated. The disease is characterized by hemorrhagic diarrhea, and the condition might be intense. Okay, infection with Eimeria bovis may be hemorrhagic also, but sometimes there will be catarrhal inflammatory conditions. I told you that the oocysts and the gammons, these are the pathogenic stage. They are superficially located in the intestinal cells. Okay, in general, the infection of the animal occurs within 3 to 6 months. When large number of calves are kept together, then in colder countries, the bedding, they used to provide the bedding that is going to provide a suitable environment for warmth and that is also providing moisture, wet conditions. So this occurs during, especially in winter conditions. That's why Eimeria zwerni infection many times is known as winter coccidiosis. Older cattle many times are regarded as carrier animals. Okay, one thing that is really good and worth to note is primary infections. That means once there is an infection, there will be some sort of immunity in the animal. Okay, so I told you that in absence of reinfection, coccidiosis is self-limiting. If there is no new coming infection, as the asexual reproduction does not continue indefinitely, there are specified numbers of asexual reproduction. I'm repeating, in case of Eimeria cervulina, there are at least 4 generation asexual reproduction that in schizogonic stage, whereas in case of Eimeria tenella, there are 2 to 3 generations schizogonic stage. Okay, then afterwards they are not going to continue for long. They are going to go for sexual reproduction. So if there is no new infections, there is no new merozoid that is going to form. If there is no new merozoid that is not going to form, whatever the merozoid that is formed, they are going to form male gametocytes and female gametocytes, fertilize each other. Then what is the next stage? Void it out, to pass out in the feces. So in absence of reinfection, coccidiosis is self-limiting disease. This is going to be important in reasoning. Okay, so the next is in case of small ruminants, we are just going to list some names. We are not going to go deep. Okay, so there are at least 14 species of coccidiosis of small ruminants, sheep, and 13 species of goat. So among these, Eimeria asata, Eimeria ovinoidalis, Eimeria ovina, Eimeria parva, these are clinically important, and Eimeria intricata. What to note, that is the largest oocyst of sheep coccidiosis, sheep Eimeria. In case of goat, Eimeria nina coli kimovi, this is the most pathogenic stage. Apart from this one, Eimeria christenseni, Eimeria legevi, Eimeria arliongi, they might also cause clinical disease. Clinical disease occurs mostly in young animal, as I have said. Okay, so young ingestion of sporulated oocysts by the young infection is going to cause disease. The infection is mostly seen during wet season of the year, that is during monsoon, when there is sufficient warmth and when there is moisture. Diarrhea is the most common clinical picture, with foul smelling, with or without blood. Why there will be foul smelling? Because many times the intestinal epithelium will be cast out, will be voided out, so that will give offensive smell. Okay, the ailing animal might lie down with their abdominal pain and weakness. Okay, one thing that is not true, important to note here again is, in case of small ruminant coccidiosis, it is written in the textbook that the histologically, there is one condition known as flat mucosa, which is caused by Eimeria of small ruminants. Okay, flat mucosa, FLAT, flat mucosa. Okay, so the clinical signs will aid in diagnosis, the history will aid in diagnosis, age of the animal, fecal examination. We can perform easily the screening of coccidiosis in fecal examination by saturated salt solution. We will observe the oocyst, which is very easy. Okay, then by post-mortem examinations, as I have said, histologically we can see flat mucosa or sometimes raised plaque, depressed lesions, that also can be seen. Okay, or there will be pin to pinhead size on that also can be seen or observed on the microscope. Okay, so coming to the treatment, there are many numbers of anti-coccidiosis, but I have listed out few. Number one is sulfa drug. We know that sulfa drug or sulfonamide group of drugs, these are folic acid synthesis inhibitor, sulfaguanidine, sulfametazine. If you can see here, 0.2% in feed, that can be given. Another group of drug is inophore antibiotics. These are causing inhibition of the ion channel, sodium potassium channel inhibition. Okay, monensin can be given 1 milligram per kilogram of body weight, salinomycin, lasolacid. These are all inophore antibiotics, and one of the most important and many times commonly used is amprolium, which is thiamine inhibitor, or in other words vitamin B1 inhibitor, which is given 10 milligram per kg for 5 days. Okay, and apart from this one, decoquinate, doltrazolil also can be given. Okay, for the last, before concluding coccidiosis of rabbit. Okay, so Eimeria stridii is the first organism, the first protozoa that was discovered by Anthony van Leeuwenhoek in 18th century. Okay, oh no, in 17th century. In 1674 he described from the liver of a rabbit. Okay, so the developmental stage, as we know, hepatic coccidiosis means the developmental stage occurs many a times in the gallbladder epithelium, so there will be huge proliferation of the intestine, the gallbladder epithelium, that subsequently results in hepatomegaly. Okay, the infection cause sudden death in rabbit with no non-specific general symptoms except jaundice. Apart from this one, the intestinal coccidiosis such as Eimeria irresidua, Eimeria magna, these also are seen in case of rabbit. And one thing that is important is Eimeria nagpurensis. Eimeria, please note it, Eimeria nagpurensis, the oocyst, in the textbook it is written, in Salisbury book it is written, it is odd shapes, OAT, odd shape. Okay, so please try to write a note regarding hepatic coccidiosis. Short notes, many a times is given in exam. Okay, so coccidiosis of pig, I think this is the last one. Okay, we'll just note down some few names: Eimeria deblici, Eimeria scraba, Eimeria spinosa. These are some the most important one. Okay, so in case of, just going back, Eimeria spinosa, there is spine in the oocyst wall. Eimeria scraba, it is, the oocyst is somewhat like brick put together, or corrugation is can be seen. Alright, the last one. Okay, Eimeria of horse, that is Eimeria leucarti. This is the largest, which is 70 to 90 by 50 to 70 micron. Alright, so with this we will conclude for this time, and by next we will try to go on the most important one, that is poultry coccidiosis.